Blue skies whisper secrets of endless possibilities.
Hi everyone. In this video, we'll go through explanation of model question paper.
If you just want model question paper with solutions, there is a video for that as well that does not have any explanation.
So part A, answer all the multiple choice questions. First one, the interval form of this particular expression, you have to choose the interval form. That is, you have to choose which brackets is the right one. So here the interval is between -4 and 6. Now what kind of brackets do we put? Right? Should it be a closed bracket or an open bracket? So whenever you have equal to here you have equal to, less than or equal to 6, less than or equal to 6. If there is equal to, that means it is included. And when you have this 6 number, and when you have this number included, then it becomes closed interval. Closed interval. Because this number is also included. And closed interval is represented by square brackets. So here near 6 you'll have closed bracket, and here it's -4 and it's just less than, there is no equal to, so this will be open interval. You'll have curved bracket. So the right option is option C, this one. Second one, if x plus 1 and y minus 2 is equal to 3 comma 1, then what is the value of x and y? So you have to equate x plus 1 equal to 3 and y minus 2 is equal to 1. So this will give you x is equal to 3 minus 1, which is 2, and this will give y is equal to 1 plus 2, which is 3. So 2 comma 3 is the right answer, option A. Third one, the degree measure of 5 pi by 3 radians is equal to, so to convert radians to degrees, convert radians into degrees, we have to multiply by 180 by pi. You have to multiply by 180 by pi to convert radians to degrees. So the right answer would be 300 degrees. The next one, the conjugate of I minus 2. Conjugate is, this is an imaginary number, right? This represents imaginary number I. Now conjugate is, you have to reverse the sign. Reverse the sign of imaginary. Reverse the sign of I, that becomes a conjugate. So you have plus I here, make it minus I. So the option C is the right answer. Fifth one, if A greater than B implies, so now you'll have to see the right option. If you have to reverse the sign less than, then you have to reverse the sign also. When greater than becomes less than, the signs will get reversed. So you have A and B, it will become minus A and minus B. So option A. Sixth one, if NC9 is equal to NC8, then NC17 is, the way we have to find n value is, you have to add up 9 and 8. If you add up 9 and 8, you'll get n is equal to 17, right? N is equal to 9 plus 8, which is 17. So now NC17 will become 17C17, and 17C17 is always 1, right? So answer is 1, option A. Now seventh one, the number of terms in the expansion of, so in binomial expansion, the number of terms will always be 1 more than the power. So you have power as 6, so it will be 1 more than that, which is 7. So 7 terms will be there. So option C is the right answer. Eighth one, if a sequence is defined as an is equal to 2n plus 5, then the first term is always a, right? This is the first term. So you have to find the first term. So if you have to find the first term, then n has to be put as 1. So it will be a1, 2 into 1 plus 5, which is 7. So right answer is C. Ninth one, the equation of x-axis is, so equation of x-axis is y is equal to 0. So when you have a graph like this, the equation of x-axis is this one. This is x-axis. The equation will always be y is equal to 0, because if you have any point on the x-axis directly, it has no y coordinate, right? It is exactly on x-axis, so there is no y coordinate, which means y is equal to 0. Thereby option B is the right answer. 10th one, the center of circle is, so they've given this circle equation, you have to find the center of the circle. See, center of the circle is given as h comma k, right? The equation is nothing but x minus h the whole square plus y minus k the whole square is equal to r square. Now h and k becomes the center of the circle. So instead of minus h, we have plus 2. Instead of minus h, we have plus 2. And instead of minus k, we have minus 3, right? See here, instead of minus k, you have minus 3. So equate it. So minus h is equal to plus 2, minus h is equal to plus 2, therefore h is minus 2. And here minus k is equal to minus 3, therefore k is equal to plus 3. The center is hk, which is minus 2, comma 3. So option B is the right answer. Let's go to 11th one. The length of transverse axis of the hyperbola. What is the equation of hyperbola? X square by a square minus y square by b square is equal to 1. And transverse is nothing but 2 times a. 2 times a. In this hyperbola, this is a. 2 times of this a is transverse axis. So now a, instead of a square, we have 9, right? We have x square by 9, which is nothing but x square by 3 square, which means a is equal to 3. So now 2 times of 3 is 6. So right option is B. Now next one. The octant in which the point minus 312 lies is, here are the 8 octants, right? This is the form. You have 8 octants. You have minus 3, which means this is minus x-axis. The value 3 is on the negative x-axis, right? That is here. This is negative x, this is positive x. So you have minus 3 here, right? So which octant is this? This is second octant. This is first. So in the second octant, you have these coordinates, because 1 and 2 is positive, that is y is positive, z is positive, x is negative, which is second octant. So you have to remember these 8 octants, right? If you notice, in the first set you have all positive z, in the second set you have all negative z, right? And you'll have to just put this different coordinates here, xy, x negative y, x negative y negative, xy negative. Same thing you repeat for the second set itself. So this particular coordinates minus 3, 1, 2 lies in second octant. You have to remember this order: 1, 2, 3, 4, 5, 6, 7, 8. So 8 octants. 13th problem. The derivative of 2x minus 3 by 4 with respect to x is, so derivative of 2x minus 3 by 4 with respect to x is, what is derivative of 2x? 2 itself. What is derivative of minus 3 by 4? 0. So answer is 2. 2. Option A. How we are going to find the derivative? You have to use the formula. You have to use this formula. Derivative of x to the power n is n into x to the power n minus 1. So derivative of x, right? 2 you can copy as is. What is derivative of x? Derivative of x is equal to, n is the power. There is no power here, so I assume it's 1. So 1 into x into to the power 1 minus 1. N is equal to 1. 1 minus 1 is 0, right? And anything to the power 0 is 1. So 1 into 1. So the derivative of x is 1, and then you already have 2 here, so it becomes 2 into 1, right? Becomes 2 into 1, which is 2, minus derivative of constant or derivative of number is 0. So the right answer is option A, which is 2. Let's look at the 14th problem. The median of the data. We have to find the median of the data. So what is median? So first step is put these numbers in ascending order, right? So when you put these numbers in ascending order, that is from small to big, you have 3, 2 times 3, then you have 4, then you have 5, 7, 9, 10, 12, 18, 19, 21. So you have put it in ascending order, right? You have put it in ascending order. So step 2 is you have to count the number of numbers. You have 11 numbers here, 11. And then you have to find the midpoint. So how do you find the midpoint? N plus 1 by 2, right? What is n? N is 11. Number of numbers here. So 11 plus 1 by 2, 11 plus 1 by 2 is 6. So sixth element or sixth number is your median. So 1, 2, 3, 4, 5, 6. Sixth number is 9. So 9 is your median. So option B. We look at 15th problem. The probability of drawing a diamond card from well shuffled deck of 52 cards is, diamond card. How many diamond cards are there in 52 cards? You have 13 diamond cards, right? Out of 52. So basically, what is the formula for probability? What is the formula for probability? Number of favorable outcomes by total outcomes. That is number of desired outcomes, right? The desired outcomes is 13. You want one diamond card out of 13 diamond cards. So you put 13 and total possible outcomes is 52, right? You can pick one card out of 52 cards. So this is total possible outcomes, 13 by 52. So if you simplify, you get 1 by 4. So option A is the right answer. Now let's look at fill in the blanks, right? You have the answers given in brackets here. So you have to fill in the blanks. If A is equal to 1, 2, B is equal to 3, 4, then the number of relations from A to B is. So the formula to find the number of relation is 2 to the power number of elements of set A into number of elements of set B will give you relations. So 2 to the power, number of elements in A is 2, number of elements in B is 2. So you get 2 to the power 4, which is 16. So 16 is the right answer. The value of cos 3 pi. Let's know what is cos pi first. What is the value of cos pi? Which is cos 180 is nothing but minus 1. Right? Cos pi is minus 1. That we will have to remember. Now anything in the odd numbers, right? Cos pi, 3 pi, 5 pi, 7 pi, so on will always be minus 1 itself. It will have the same value of cos pi. So it's going to be minus 1. So if you take a unit circle is circle with 1 centimeter as the radius. So if you take this unit circle, right, the radius is 1 unit, right? Cos is always x-axis coordinate. So on this side it's going to be minus 1 and this side is going to be plus 1. 180 degrees on this side, right? And this side, what is the x coordinate? It's always negative, right? This side is always negative. So you have minus 1. So cos 180 is always minus 1. So all the odd numbers, cos pi, cos 3 pi, cos 5 pi, cos 7 pi and so on will be minus 1. All the even numbers like cos 0, cos 2 pi, cos 4 pi, cos 6 pi will be plus 1 because it's on the positive side of the x-axis. Positive side of x-axis is always plus 1 in the unit circle. So cos 0 is 1 and cos 360 is 1, 4 times 180. So all these even numbers will have 1 as the answer. Here we have odd number 3 pi, so it's minus 1. 18th one, the value of 7 factorial by 5 factorial. So simply you have to put 7 into 6 into 5, stop it at 5 factorial, and the denominator you have 5 factorial, both will get cancelled. So it will be 7 into 6, 42. 42 is the right answer. So we'll go to the 19th one, the slope of the line passing through the point. What is the slope formula? y2 minus y1 by x2 minus x1. So you assume that this is x1 y1, this is x2 y2. Substitute the coordinates, minus 2 minus of y1, which is minus 2. You simplify, substitute the numbers and simplify, you get 0 as the slope. 20th one, the derivative of x square minus 2 at x is equal to 10, right? First of all, you have to find derivative of x square minus 2. Again, what formula we have to use? N into x to the power n minus 1. What is the power here? 2. 2 into x to the power 2 minus 1, which is 2x. So 2x. And derivative of a number is always 0. So derivative is 2x. And you have to substitute value of x as 10. 2 into 10, which is 20. So 20 is the right answer. Let's look at part B questions. Answer any 6 questions. This is from sets. Let A is equal to 1, 2, 3, 4, 5, 6. B is equal to 2, 4, 6, 8. Find A minus B and B minus A. So A minus B is nothing but elements in set A but not in B. So you should have elements in set A but not in B. So basically you should not have 2, 4, 6, 8. So what are the remaining elements? 1, 3 and 5. So this is A minus B. B minus A is nothing but elements in B but not in A. So you should have elements in B that is not in A, which is nothing but 8. Because 2, 4, 6 is there in set A. 8 is not there in set A. So 8 is the answer. Let's look at next problem. List all the subsets of the set AB. Very simple. Put a null set A, set B, and set with A and B. Next one. Find the multiplicative inverse of 2 minus 3i. So whenever you have to find the multiplicative inverse, you have to divide both of this by a square plus b square. Right? A square plus b square. So you have a is equal to 2 and b is equal to minus 3. So substitute a and b values. So you put 2 by 2 square plus minus of 3 square because b is minus 3. Similarly here, split it. So you have I into b by a square plus b square. Substitute all the values. Finally you will get multiplicative inverse, which is 2 by 13 plus 3i by 13. So what you have to remember is you have to divide by a square plus b square and split this. A by a square plus b square and ib by a square plus b square. And a is 2 here, b is minus 3. Right? Substitute and you will get the final multiplicative inverse. Now, next problem. If x plus iy is equal to a plus ib by a minus ib, prove that x square plus y square is equal to 1. So simple, you have to rationalize the denominator. Rationalize, right? First rationalize. How do you rationalize? Take the denominator, multiply the numerator and denominator with this particular denominator expression, but with reverse sign. You have minus ib, you have to make it as plus ib. Multiply both numerator and denominator with this, right? And then substitute I square as minus 1. I square is minus 1 everywhere, and then you'll get x plus iy, right? This is the expression for x plus iy. Similarly, what is x minus iy? So in the center here you have plus, just replace it with minus. So you get x minus iy, right? Now you multiply this one, multiply this one with this one, right? Then that's when you'll get x square and y square. See, you have to get x square and y square to prove, right? So you multiply these two, you'll get x square and y square. So that's what we are doing. We are multiplying this entire expression with this expression. So you have to do it carefully, right? And then you have to substitute I square as minus 1, right? You substitute I square as minus 1 wherever you have I square. And finally, you'll get this answer as 1. You know, when you multiply x plus iy into x minus iy, it's going to be, it's of this form. A plus b into a minus b is nothing but a square minus b square. This is a formula. So you can directly use this formula. Instead of multiplying 1 by 1, use this formula. A plus b into a minus b is a square minus b square. This is x. And what is iy? This is iy. This is iy. 2ab by a square plus b square. This is iy. And a square minus b square by a square plus b square is x square. So basically, this is x, this is y. This is x, this is y. So you take square of this and take square of this and then subtract it. Simplify it, you will get 1 as the answer. And also, whenever you get I square, you should put it as minus 1. Now, 26th one. Solve inequality and show the graph of the solutions on number line. Now, inequality. So this is an inequality because you have less than here, right? Anytime you have less than or greater than, it becomes inequality. So what you have to do, you have to first find the value of x, right? So you simplify this, and then you get x less than 2. So you draw a number line, x less than 2. At 2, put an open interval, open circle. At 2, you put an open circle because it is less than 2. 2 is not included, right? It's not included. 2 is not included. So it's open circle, right? If it was equal to, then it will be closed circle like this. But here, equal to is not there, right? It's only x less than 2. So less than 2 means it's negative numbers, 2, 1, 0, and then negative numbers. So this is less than 2. So draw this line from 2 to minus infinity like this. Darken the line to identify that this is the solution. So range is minus infinity to 2 for real numbers. And if you look at natural numbers, then it will be, you have to write it like this, minus 4, minus 3, minus 2, minus 1, 0, 1. But this is enough. Representing this on the number line is enough. 27 problem. How many 3-digit even numbers can be formed from the digits 1 to 6 if the digits can be repeated? 3-digit number, right? 3-digit number. Put these 3 boxes. How many ways you can put the first digit? 6 ways. Digits can be repeated, right? So 6 digits. Second digit, again 6 ways. Third digit, it should be even number. So what is the possibility? It can be 2 or 4 or 6. So 3 ways. So the final answer is multiply all this. 6 into 6 into 3. 108. Let's look at binomial theorem problem. Expand 1 minus 2x to the power 5 using binomial theorem. So we have to remember the formula. NCR into x to the power n minus r into a to the power r. Now, what do we have in place of n? N is equal to 5. What is the first term? X. Nothing but 1. What is second term? A. Second term is a, which is minus 2x. Right? Now, NCR, substitute all the values. Right? You can use the tips and tricks. There is a video which talks about binomial theorem techniques of expanding it easily, right? Without having to struggle. So let's try this out. Okay, let's try to use this technique. So you have n is equal to 5. N is equal to 5. First term is 1. First term is 1 and second term is minus 2x. So what I'm going to do is, I'm going to first write the NCR values. 5c, 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 5, n is 5, so you'll have 6 terms. So 5c, 5c, 5c. Then I'll put to first term. First term is my 1. So 1, 1, 1, 1, 1, 1. Now what is second term? Minus 2x. Put that. Minus 2x, minus 2x, minus 2x, minus 2x, minus 2x. Now I'll have to think about powers. So you will start with this 5CR, right? So you start with 0, 1, 2, 3, 4, 5. Now you will have to put the powers for first term. Here it's n minus r. So 5 minus 0. So we'll start from the highest power. 5, 4, 3, 2, 1, 0. Now for R, you'll go from 0, 0, 1, 2, 3, 4, 5. Now you put all plus sign in between. That's all. So you've expanded it. Now you have to carefully simplify it, right? It's better to remember all the 5C values, right? Like 5C0, 5C1, 5C2, 5C3, 5C4. It's better to mug up, and it's easy to mug up. So sequence is like this: 1, 5, 10, 10, 5, 1. So the first two and the last two will be same. The middle two will remain the same. So look at again the tips and tricks videos. You have tips and tricks to remember this sequence also. So 1, 5, 10, 10, 5, 1. If you remember this, you can directly substitute. So let's go to 29th problem. Find the equation of the line intersecting the x-axis at a distance of 3 units to the left of origin with slope as -2. You have 2 points here, x comma y, x0 comma y0.
Put
x0 comma y0 is nothing but
as
origin,
-3,
which is 0, 0.
Substitute
So
minus
you
3,
put the 0, 0 for
then
the retain yx as is, right? And then you'll get the equation of the circle. So you can write this equation also as y is equal to minus 2x minus 6, right? So this is in the form y is equal to mx plus c. This is a general equation of line. So you get the equation as y is equal to minus 2x minus 6. Let's look at 30th problem. Evaluate limit x to the power 15 minus 1 by x to the power 10 minus 1. Limit x tends to 1. So again you'll have to use this formula theorem. Limit x tending to a, x to the power n minus a to the power n by x minus a is equal to n into a to the power n minus 1. We'll have to use this theorem here. First of all, we have to get it in this particular form. So you can write this as 1 to the power 15, right? You can write this as 1 to the power 15, and here you can put 1 to the power 10. Now you have this numerator in this form, x to the power n minus a to the power n. But denominator should have x minus a. That means denominator should have x minus 1. You don't have x minus 1 in the denominator. So what you do is, you divide numerator and divide denominator by x minus 1, because you want x minus 1 here to satisfy this theorem. So you divide both numerator and denominator with x minus 1, and then you can apply this theorem. So instead of n you have 15, right? And instead of a, this is a. Instead of a you have 1. 1 to the power anything is 1 itself, right? So actually you get 1 to the power 15 minus 1. So 1 to the power 15 minus 1 is 1 itself. So 15. Similarly here also, n is equal to 10. So you get 15 by 10, which is 3 by 2, which is 1.5. Next one, 31st problem. A die is thrown. Describe the following events. A number is less than 4, which is true, right? A die is thrown. Describe the following events. A number less than 4, a number not less than 3. So when a die is thrown, you can get numbers less than 4. So you can call this first event as A. Number less than 4. What is the possible outcomes? 1, 2, 3. These are the numbers on the dice which are less than 4. Next event, number not less than 3. Number not less than 3 means number greater than 3. What are the numbers that can be greater than 3? 4, 5, 6 in a dice, right? 4, 5, 6. Now, if you take A union B, right, you'll get the entire sample space. 1, 2, 3, 4, 5, 6. You'll get the entire sample space, which means whenever you take union of two events and you get the sample space, then you can call it as events are exhaustive. Why it's called exhaustive? Because it contains all the outcomes in the sample space. Now you take A intersection B. Here it is null. There is nothing common between this set and this set. Nothing is common. So it is null set. Since it is null set, you can call events are mutually exclusive. What do you mean by mutually exclusive? Outcomes that come in event A don't come in event B, or outcomes that come in event B don't come in event A, right? They don't have any common elements, no common outcome. That's when it becomes mutually exclusive. If one occurs, the other doesn't occur, right? Either you can have a number less than 4 or number not less than 3. Can you have both? That is, you can't have a number less than 4 and a number greater than 3. Number less than 4 and number greater than 3. It's not possible, right? Any one can be true. Either you can get a number less than 4 or you can get a number greater than 3. Both are not possible. Therefore, this is called as mutually exclusive. So, the conclusion is events are exhaustive and mutually exclusive. So, let's look at part C related problems. Answer any 6 questions. So, 32nd problem is, let universal set B 1, 2, 3, 4, 5, 6. Set A is given, set B is given. Prove that A union this entire A union B complement is equal to A complement intersection B complement. So first take LHS. First take LHS as A union B complement. So first find A union B. What is A union B? 2, 3, 4, 5. Complement of this is you have elements in the universal set but not in this. You should have elements in the universal set but not in this. So you have 2, 3, 4, 5. So what are the remaining elements in universal set? Other than 2, 3, 4, 5, what are the elements in universal set? You have 1 and 6. 1 and 6 are the elements in universal set which is not there in this set. So 1, 6. Now this is LHS. We go to RHS, take A complement intersection B complement. First we find A complement. Now what is A complement? Elements that are there in the universal set but not in set A. Right? Elements that is there in universal set but not in set A. So you have 2, 3 here. Remove this 2, 3. Take the remaining elements. So it's 1, 4, 5, 6. 1, 4, 5, 6. Similarly, take B complement. Now, for B complement, you should take elements in universal set which is not in set B. So ignore 3, 4, 5. Ignore 3, 4, 5 and take the remaining elements. So you'll get 1, 2, 6. Right? Now you find the common elements, intersection between these two sets. 1 and 6 is common. So this is the answer. Now if you notice LHS and RHS, it has the same set. So we can say that this statement is true. A union B complement is same as A complement intersection B complement. Now we will look at 33rd problem. Let f of x is equal to x square and g of x is 2x plus 1 be two real functions. Find f plus g, f minus g and fg of x. It's very simple. So you can write f plus g of x as f of x plus g of x. Right? F of x plus g of x. What is f of x? X square. What is g of x? 2x plus 1. So you'll get this particular expression. Similarly, f minus g is nothing but f of x minus g of x. Substitute. And fg of x is f of x into g of x. Remember this. This is into. Multiply and you'll get this expression. Simple. Now let's look at 34th problem. Prove that cos 3x is equal to 4 cos cube x minus 3 cos x. This is nothing but cos 3x formula, right? So you have to split cos 3x as 2x plus x. Right? And then you have to remember the formula. Cos 2x, that is cos a plus b formula you have to remember. Cos a plus b is nothing but cos a cos b minus sin a sin b. You have to remember this formula. Now, instead of a, you have 2x. Instead of b, you have x. Substitute it here. Finally, you will get this particular expression. And remember, again, you will have to substitute cos 2x. You will have to put which formula? Cos based formula. Cos 2x is 2 cos square x minus 1. You have to put this formula. 2 cos square x minus 1 here. And then sin 2x, you can put, what is sin 2x? 2 sin x cos x. So put 2 sin x cos x here. So now everything is in the form of cos x or sin x. Now you have eliminated this 2x and here 2x. Now you simplify. And then finally, if you notice in this expression, you have everything in the form of cos. You don't have sin anywhere. So you have to eliminate the sign now. How do you eliminate sign? You have to remember this formula. Sin square x plus cos square is equal to 1. So therefore sin square x is 1 minus cos square x. Sin square x is 1 minus cos square x. Substitute and then finally you will get this particular expression and you will get that LHS is equal to RHS. 35th one. If cos x is minus half, x lies in third quadrant, find the values of other 5 trigonometric functions. If cos x is minus half, what is cos formula? Adjacent by hypotenuse. Adjacent by hypotenuse. Right? If this is theta, adjacent is this one or the base, hypotenuse is this one, longest side. Right? So it's minus half, right? So minus 1 is in the base, 2 is the longest side, like this. So now you'll have to find sin x. Sin x is opposite by hypotenuse, this one. We don't know what is this. Using Pythagoras theorem, we can find this. Pythagoras theorem is longest side, this hypotenuse square is equal to square of both the sides, right? Adjacent square plus opposite square, right? Square of this side and square of this side, when you add, this will be the square of longest side, hypotenuse square. Now using this formula, you can find opposite side value. So 2 square minus 1 square would be root 3. So this value is nothing but root 3. So sin x is opposite by adjacent. So it's going to be minus root 3 by 2. Now why is it minus root 3? Because they said x is in the third quadrant. In the third quadrant, this is first, second, third, fourth. In the third quadrant, you have x and y as negative. So x lies in the third quadrant. In the third quadrant, y is negative, right? That's why we put negative here. We put negative here because sine x is nothing but y value. Y coordinate is sine, right? And it's in the negative axis because it's third quadrant. This is third quadrant. Y is negative, so you'll have minus sine, right? Sine will have negative values. So you'll say sine x is minus root 3 by 2. Minus root 3 by 2. Now we know cos x, we know sin x. Let's find tan x, cot x, secant x, and cosec x. You have to find all the trigonometric functions. So tan x is opposite by adjacent. So we know opposite side is minus root 3 and adjacent side is minus 1. So minus root 3 by minus 1, which is plus root 3. Cot x is reverse of this, 1 by root 3. Secant x is 1 by cos x. So reverse of this, reciprocal of this. Instead of minus half, it will become minus 2 by 1. Cosecant x is reverse of sin x, right? So it's root 3 here. It's root 3 by 2 minus root 3 by 2. It will become 2 by minus root 3. 36th one. Express this particular expression in the form of a plus ib. Simple. Again, rationalize the denominator. How do you rationalize the denominator? Take the denominator and reverse the sign. You rationalize the denominator. Take this denominator term, reverse the sign. It's minus here, put plus. Multiply both numerator and denominator with this expression here. You're multiplying numerator and denominator with this particular expression with opposite sign. You simplify. Remember to put y square as minus 1 wherever possible. And then you'll get this 1 plus 2 root 2i, which is the form of a plus ib. 37th one. Find all pairs of consecutive odd positive integers, both of which are smaller than 10, such that their sum is more than 11. Consecutive means next to each other. So let's assume the numbers, the two numbers, right? Consecutive odd numbers be, say x and x plus 2, right? Because if x is 5, say for example, then the next odd number is 7. And if x is equal to 7, next odd number is 9. So basically, there is a difference of 2, right? From the first number to next number, there is a difference of 2. So therefore, we assume that first number is x and second number is add 2 to that first number. That's the second number, x and x plus 2. Now, what is the condition? Both of which are smaller than 10. So x is less than 10 and x plus 2 also is less than 10. And their sum is more than 11. So when you add this 2, their total should be more than 11. So x, if I add with x plus 2, it should be more than 11. Right? For example, say this is 5. This will be 5 plus 2. So which is 5 plus 7. It should be greater than 11. Which is, in this case, it is greater than 11. 5 plus 7 is 12, which is greater than 11. So 5 and 7 are satisfying the conditions given here. Both are odd numbers. They are consecutive. That means immediate numbers. And it is satisfying this rule. Smaller than 10. 5 and 7 both are smaller than 10. And their sum is more than 11. So when you add them, it's more than 11. Now, how do we solve this? Right? So we'll put all the inequalities. This is one inequality. This is second inequality. And this is third. Right? Third inequality is x plus 2 is greater than 11. Now what we should do is we have to solve. We have to find the value of x. Right? So if you solve, this will be 2x plus 2 greater than 11, which means x is greater than 11 minus 2 by 2. That is x greater than 9 by 2. What is 9 by 2? It's 4.5. Now these are integers. Integers means it will be complete numbers. There will be no decimal. Integers means no decimal. Right? So what is the integer greater than 4.5? It's 5. 5 is an integer. What are integers? Like 4, 5, 6, 7. These are integers. Right? So number greater than 4.5. What is the number greater than 4.5? It's 5. You can't consider decimal. It has to be integer. So we know it should be x greater than 4.5, or you can write x is greater than 4. And then we've also put x less than 10. Now, what is the range? Let's bring this in the form of less than itself. This is less than. We'll make this also as less than. So what I'll do, I'll say 4 less than x. If I reverse the numbers, then the sign will also reverse. So it's greater than, it will become less than because I have reversed the numbers. And this is x less than 10. So I can write it as like this: 4 less than x less than 10. This is my range. Right? X should lie between 4 and 10. Right? So x should be between 4 and 10. Now it cannot be 4 or it cannot be 10. These numbers are not included. It is only less than. There is no equal to here, right? There is no equal to. Therefore, 10 and 4 are not included. Numbers between 4 and 10. So it will be 5. So your x will be 5, 6, 7, 8, 9, and 10. But it should be an odd number. It should be odd number. So therefore, it will be just 5, 7, 9. This will be the values for x. Now this is first number. This is first number. Now what will be the range for second number? What is second number we assumed? X plus 2. You add 2 to first number, that will be your second number. So what will be the set? It will be, if I add 2 to 5, it will be 7. 2 to 7 will be 9. And 9, if I add 2, it will be 11. But what is the rule here? Rule is that both the numbers should be smaller than 10. Now I cannot consider 11 because it should be smaller than 10. Right? Both numbers should be smaller than 10. Right? Both of them. So it's only 7 and 9 that we will get. Now, you know the first number, you know the second number. So what are the numbers now? What are the pairs? What are the pairs? Simple. 5 and 7. 7 and 9. That's all. We can't take 9 because if I take 9, then I'll have to add 2 to it and it will become 11. And every number should be less than 10. So 11 cannot be taken. So it will just be these two pairs. This is the answer. Let's go to next problem. The sum of first three terms of a GP is 13 by 12 and their product is -1. Find the common ratio and the terms. So the sum of three terms of GP are given. So we assume in GP, what is the sequence? It is A by R, A and AR, and it goes on. AR square, AR cube. This is how the sequence is in GP. So we need three terms. So we'll assume these are the terms. Okay. And sum of this. So when you total all this, you'll get 13 by 12. And their product is -1. Product means when you multiply all of this, you'll get -1. So now what we will do, we'll add this, right? R will become the LCM here. R will become the LCM. So this will go once. Assume that denominator is 1. So this will go R times. Because if I multiply 1 into R, then I will get LCM R. So I multiply the numerator with R. So it will be AR. Similarly here also, I multiply the denominator value with R. Then I'll get LCM as R. So I'll multiply the numerator. So AR into R is AR square. This is equal to 13 by 12. Now, let's go to the next one. Product. When you multiply all these three terms, you get -1. So here R and R will get cancelled. So you'll have A cube as -1. So what will be the value of A? Right? If I have A as -1, A cube will be -1 into -1 into -1, which is -1. Right? So A cube will become -1, which means that A should be equal to -1. If A is equal to -1, then A cube will become -1. So A is -1. Now I have the value of A, right? I know the value of A. I'll substitute this value of A in this particular expression, right? So I'll get this expression now, right? So you will get a quadratic equation here. Then you need to find the values of R. How would you find the values of R? R is nothing but common ratio, right? R is common ratio. We need to find the value of R. So we use this formula. This is A, this is B, and this is C, right? Plus A, plus B, plus C. Put all these values here, substitute. You'll get two values of R, 4 by 3 and 3 by 4. -4 by 3 and -3 by 4. Now, so therefore, common ratio is -4 by 3 and -3 by 4. Now we'll have to find out the terms. What are the terms? A by R, A and AR. We know the value of A and we also know the value of R, right? You substitute the value of R, substitute the value of A, and this will be your three terms. 3 by 4, -1 and 4 by 3. Let's look at next problem. Derive the equation of a line with x-intercept as A and y-intercept as B in the form x by A plus y by B is equal to 1. So x-intercept means it is cutting, the line is cutting the line. The line is cutting x-axis at coordinate A. That is when the value of x is equal to, A, this particular line is cutting this particular point, right? Similarly, y-intercept means this line is cutting this particular y-axis at B. Now you have to find the equation of this line. have to find the equation of this line. So we know the formula, right? We know one formula. So we can use this formula, 2-point formula, right? We'll use this 2-point formula. Y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1, and substitute these points. So this is cutting x axis. So you have the x coordinate given as a and y coordinate as 0. Because it's on the x axis, there is no y coordinate or y value. So this is 0. Similarly here, the line is cutting the y axis. So x coordinate is going to be 0 because there is no x value. It is exactly on the y axis. And the value of y coordinate is b. So you have 0 comma b here. Now you assume that this is x1 comma y1 and this is x2 comma y2. Substitute the values here, right? And finally you will get this particular form, x by a plus y by b is equal to 1. So thereby we will get the proof. Now we look at 40th problem. Derive the equation of the parabola with vertex 0, 0 passing through point 2 minus 3 and symmetric about y-axis. Now you have to derive the equation of parabola. Vertex is 0, 0 means it's in the origin. This is the vertex. The parabola passes through point 2 minus 3. That means when x is 2 and y is minus 3, that is here. Y is minus 3 here and x is 2, right? Somewhere here. So this is the point, assume, right? This is the coordinate. So parabola passes through this point, right? So you draw a parabola here and it's symmetric about y-axis. That means you have y-axis. It is symmetric. That means it's equally, the curve is equally on both the sides of y-axis. So you have parabola curve here and you have this curve here on the sides of y-axis. So therefore it is downward parabola. Point is at this part in the fourth quadrant. This is the point, right? The point is in the fourth quadrant. So obviously it's going to be downward parabola because it's symmetric around y-axis. It's around the y-axis, around the y-axis. Now, what is the equation for downward parabola? It is nothing but x square minus 4ay. X square minus 4ay, right? Now, there is a video on parabola. There's a complete playlist on parabola. There are ways to remember these parabola characteristics and parabola types. So you can remember their equations, their focus, their directrix, length of latus rectum, etc. So you can go through that playlist. Now here in downward parabola, it's going to be x square minus 4ay. Now the clue is here the y-axis is negative. The y-axis is negative, so obviously it's going to be minus y, right? Here in the downward parabola, it's around the y-axis, which is negative. This is negative y-axis. Therefore, you have minus here, right? And focus is going to be on the y-axis. Focus is on the y-axis because the parabola is symmetric around y-axis. So focus is on the y-axis. Therefore, this is going to be x square is equal to minus 4ay. Now, the point is given 2 minus 3. You take this equation, substitute 2 and minus 3. Instead of x, you put 2. Instead of y, you put minus 3. Substitute, you'll get value of a. Now what you'll do, you'll again take the same equation and leave x and y as is. Instead of a, you put this value that you've got 1 by 3. And then you'll get this kind of an equation. 3x square plus 4y is equal to 0. Or you can write as 3x square is equal to minus 4y. So this becomes a parabola equation. Now we look at 41st problem. Show that the points are the vertices of a right angle triangle. So you have 3 points. You have to show that they are the vertices of a right angle triangle, right? Vertices of right angle triangle. Now in right angle triangle, we have Pythagoras theorem. That is square of the longest side. This is the longest side or the hypotenuse. The square of the hypotenuse is the sum of squares of these two sides. So AC square is equal to AB square plus BC square. Now, how do we find AB? Use distance formula, right? So what we will do is we'll use this AB coordinates that is given, right? We'll subtract the corresponding coordinates here, right? Like this. So we'll form AB square is equal to A is equal to A is nothing but 0, 7, 10 and B is nothing but minus 1, 6, 6. Minus 1 minus 0 the whole square plus 6 minus 7 the whole square plus 6 minus 10 the whole square. So this will be length of AB, right? So we'll get, when you simplify, you will get 18 as the answer. AB square will be 18 when you simplify. Similarly, we'll find BC square, right? BC square would be between these 2 points. What is point C? Minus 496. Minus 496. So here what we will do? We'll take minus 4, minus of minus 1, plus 9 minus 6, plus 6 minus 6. Now all of this will take as squares. So this will be minus 4 plus 1, which is minus 3 the whole square, plus 3 square, plus 0 square. So this is going to be 9 plus 9, which is 18. So we have BC square is also 18. Similarly, we find AC square, right? We'll first find AB, BC, then we'll find AC. So now, when you simplify AC, here you will get 36, right? AC square is 36. Now, you substitute here. AB square plus BC square should be AC square. So here you will get 18. Here also you will get 18. And AC we got as 36. So this is equal to 36 is equal to 36. Therefore, we can say this is a right angle triangle. Therefore we can say the given points are the vertices of a right angle triangle. Because of this particular rule, we are able to satisfy this rule. Now we look at next problem. Find the derivative of sin x with respect to x from first principles. Right? You have to find the derivative of sin x. What is the derivative of sin x? It's nothing but cos x. Now we'll have to derive this using first principles. So we should remember the formula here. What is the formula? Derivative of some function is nothing but limit h tends to 0, f of x plus h minus f of x by h. So this formula is important, right? We have to remember this formula, right? Now you have function of x plus h. Now f of x is sin x. So what will f of x plus h be? It will be nothing but sin x plus h. Instead of x, I'll put x plus h, right? So it will be sin x plus h. And here I have f of x, I'll put sin x. H I'll copy as is here. Now I'll use transformation formula, right? Sin C minus sin D here. Sin C minus sin D is equal to 2 cos C plus D by 2 into sin C minus D by 2. So instead of C, we have x plus h. Instead of D, we have x. So it will be x plus h plus x by 2. Similarly here, x plus h minus x by 2. So you'll get this particular value. Now, you notice here, there is h, sin h by 2 and there is h here. So we can use that theorem, right? Limit theta tending to 0, sin theta by theta is equal to 1. Now, to satisfy this, you should have h by 2 here. You should have h by 2 here. Then you can apply this theorem. But I don't have h by 2 now. So what I will do is, I'll multiply and divide by 2 here. In the denominator, I'll multiply and divide by 2. That way I'll get h by 2. Right? I'll get h by 2. And I'll be left with one more 2 here. And here, I'll substitute h as 0 here. Right? In this particular expression, I'll substitute h as 0. So it will become x plus h is 0. So x plus 0, which is cos x. And here, the sin h by 2, this portion, h by 2 and h by 2 will become equal to 1. Right? This will become equal to 1. And then I have 2 already here. So it will become half. And 2 and this particular 2. So it will become half. And finally, this 2 and 2 will get cancelled. I'll be left with cos x. So therefore, derivative of sin x is cos x. Now we look at part D related problems. First one, define greatest integer function, draw the graph, write the domain and range. So greatest integer function is nothing but a function from real number to real number, which takes the value of greatest integer less than or equal to x, right? Now, how do you draw the graph? So what happens in a greatest integer function? If you have values between minus 1 to 0, say you have values such as minus 0.1, minus 0.2, minus 0.99, right? If you have values like this, then the final function value or the y value is going to be lesser of these two values. That is, lesser of these two values. What is lesser of these two values? It's minus 1. Between minus 1 and 0, the least value is minus 1. So minus 1 becomes the y value, or value of greatest integer function is minus 1. This way. Say you have values from minus 1 to minus 2. right? Say minus 1.1 or minus 1.2. Then the function will have minus 2 as the function value because this is between minus 1 and minus 2, because between minus 1 and minus 2 is the least integer. So the function will return minus 2 as the answer. And between minus 3 and minus 2, whatever values you have here, whatever x values are there, the y value is going to be minus 3, because between minus 2 and minus 3 is the smallest number. That's why you see that all these numbers minus 3, minus 2, minus 1 will have dot here. It's covered, which means minus 3, minus 2, minus 1 will be the function values. And these values here would be open circle. Similarly, if you see values in the positive side, say you have x values between 0 and 1, say 0.1, 0.2, then the y value or the function value will be 0. What is lesser between 0 and 1? 0 is lesser. So 0 is a covered circle here, covered circle. And if you have values, x values between 1 and 2, say 1.1 or 1.2, 1.3, then the least of these two values, least of values between 1 and 2 is 1. This is the least integer value. It should be integer value, not a decimal value. So integer, least integer value between 1 and 2 is 1. So therefore, this 1 is covered circle, 2 is open circle. Similarly, if you have values between 2 and 3, this one, if you have values between 2 and 3, for all values between 2 and 3, say 2.1, 2.2 and so on, the function will give you least integer value. Which is the integer here? You have two integers, 2 and 3, right? Remaining are decimals, right? But the function will always return integer value, and it's going to be the least integer. Between 2 and 3, which is the least integer? It's 2. Therefore, 2 is covered, right? Similarly here. So this way you can plot the greatest integer function, right? And then we have to write the domain. Domain can be any real number, right? A real number is anything. It could be integers, it could be decimals, it could be fractions, anything. So it's infinite. From minus infinity to infinity, you can take any number. But what is a range? Range is nothing but all integers. The function values would be only integers, all integers. Now let's look at this next problem. Prove that this particular expression is equal to tan x. So we'll take LHS first. Let's take that this entire thing is LHS and tan x is RHS. So we will club the sine 5x with sine x, right? And then leave out the sine 3x separately. Now we'll use this formula. Sine c plus sine d is nothing but 2 sine c plus d by 2 into cos c minus d by 2. We'll have to mug up this formula. Sine c and sine d, when you add two sine functions, you will get sine and cos. You will get product of sine and cos. You will have to take c plus d and divide by 2. So now you will take 5x and x. So 5x plus x is 6x, right? You will get 5x plus x by 2. You will get 6x by 2, which is 3x. So you have 3x here. Similarly, when you subtract, you will get 5x minus x by 2, which is 4x by 2, which is 2x. So you're getting 2x here, right? And then you just copy this 2 sine 3x. Similarly, in the denominator also we can use the formula. It will be cos c minus cos d is equal to minus 2 sine c plus d by 2 into sine c minus d by 2. Then you evaluate, you will get this particular expression. You will see that sine 3x and sine 3x will get cancelled. 2 and 2 will get cancelled. You will be left with cos 2x minus 1. Here you can write cos 2x. What is cos 2x? You can nothing but 1 minus 2 sine square x. This is cos 2x. And then you already have 1 here, right? So this 1 and 1 will get cancelled. And then you have sine 2x in the denominator. So this will be nothing but minus 2 sine square x by sine 2x. What is sine 2x? 2 sine x into cos x, right? Sine 2x is 2 sine x into cos x. So 1 sine x and will get cancelled. 1 sine x and sine x will get cancelled. 2 will get cancelled. So you'll be left with minus sine x by cos x. You have a negative sign here, right? Here you have negative, right? So you'll get, finally you'll get sine x by cos x, which is tan x, which is equal to RHS. We look at this particular problem. Find the number of arrangements of the letters of the word independence. In how many of these arrangements the words start with P and the words begin with I and end in P? So first we need to find the total number of arrangements. So we need to find the number of letters. There are 12 letters in this word independence. So 12 factorial. Divide by the repeated kinds. Repeated kinds. Now what are the repeated letters? You have N repeated 3 times, D repeated 2 times, E repeated 4 times. So 3 factorial into 2 factorial into 4 factorial. Put this in the denominator. So this is the total number of arrangements. Now first question is, we need to find number of ways in which the words start with P. Word should start with P. If you have words starting with P and then the remaining 11 letters can be arranged. Starting letter is fixed, right? It's in the first position. The remaining 11 letters you can arrange in multiple ways. So we have to find the total number of ways. So what are the remaining letters? 11 letters. So 11 factorial by repeated kinds. Now in the remaining letters, we should see the repeated kinds. Same thing, N, D, E. 3 factorial into 2 factorial into 4 factorial. This becomes the words that start with P. Now similarly, second one, we need to find number of ways in which the words begin with I and end in P. So it begins with I and ends with P. So this is fixed position. You cannot make any changes. The position is fixed. You can only change the remaining letters. What are the remaining letters? 10, right? So it will be 10 factorial by repeated kinds. Same thing, 2 factorial by 3 factorial into 4 factorial. Repeated kinds. Now next problem, prove that for every positive integer, you'll have to prove the binomial theorem here. You have to prove that a plus b to the power n is this entire expansion, right? So you'll use mathematical induction here. So in mathematical induction, first you'll take n is equal to 1. So in this entire expression, substitute n as 1, right? So you'll get one particular expression. You'll get this. You'll get p of 1 here. You assume that p of n is this entire expression. N becomes 1. So p of 1 is a plus b. So you'll first take n is equal to 1. You'll get p of 1, right? So we say p of 1 is a plus b to the power n. So n is 1. So it'll directly be a plus b, right? And even if you use the expansion, this entire expansion if you use, n is 1, right? So this is the expansion. So instead of n you put 1. So 1c0 a to the power 1 plus 1c1 a to the power 1 minus 1, which is 0, and b. We'll have to stop it here because we've already got 2 terms, right? You have 0 and 1, right? We stop because we reached 0 here. So we have to stop. Now if I simplify, what is 1c0? 1c0 is nothing but 1 itself. 1 into a. And what is 1c1? 1c1 is also 1. 1 into b. So you get a plus b. Now if you look at both of this, whether you use expansion or you directly substitute, right, n as 1 in this expression, you'll get the same answer, a plus b and a plus b. Therefore we can say p of 1 is true. When n is equal to 1, this particular expansion is true. Hence p of 1 is true. Now what we will do, we'll assume, we'll put n is equal to k, right? N is equal to k, some constant, some integer k. Now you substitute, wherever you have n, substitute k. You'll get this particular expression. Now next thing what you'll do is, you'll put, instead of n, you'll put k plus 1, right? So you'll get k plus 1, a plus b to the power k plus 1. Now wherever you have k, you put k plus 1. You'll get this, right? You'll get this entire expression. Now what you'll do, you'll split this expression. You can split a plus b to the power k plus 1 as a plus b into a plus b to the power k. This way you can split. This is one expression. Now here, after substituting k plus 1, here you'll get this particular expression after substituting k plus 1. Now what you can do is a plus b, that is LHS, we'll take a plus b to the power k plus 1, and we can write this as a plus b to the power k into a plus b to the power 1. This is nothing but a plus b to the power k plus 1. We can split it like this, right? Now what is a plus b to the power k? We'll have to substitute this entire expression here. Instead of a plus b to the power k, substitute this entire expression. And then you put this a plus b as is. Then you multiply. So from that entire expression, this is a plus b to the power k. And this is just a plus b, right? Here you're substituting. Instead of a plus b to the power k, you're putting this particular expression and putting a plus b. So when you multiply, you'll get kc0, a to the power k into a is, a to the power k into a is k plus 1, a to the power k plus 1. bases are same. So you assume that there is power 1 here. So 1 plus k plus 1. Similarly here, kc1 you'll copy as is. You have a to the power k minus 1 into a. So assume the power is 1. So when you add 1 here, 1 and 1 will get cancelled. You'll be left with k, like this, right? And then you have b here. So like this you multiply term by term with a and with b. So you'll get this long expression, right? All these terms you'll get. Now you can look at similar terms. So you have akb here. Here also have akb. So you take this as common. So you'll be left with kc1 and kc0. kc1 and kc0. Similarly, you take common terms between this one. You have a to the power k minus 1 and b square here also. So when you take common terms, you'll get this. So like this, you'll do this until the end of the expression. In combinations, we have one formula. kcr plus kc minus 1 is equal to k plus 1 cr. Right? We have this formula, that is ncr plus ncr minus 1 is nothing but n plus 1 cr. Right? We have this. So using this combinations property, we'll substitute here. So if you notice, we have here kc0 and kc1. kc0 and kc1. So you'll put k plus 1. So it will become k plus 1 and c1. Right? So use this here for every term. So we'll get k plus 1 everywhere here. Right? Now if you compare this particular expression with this, with what we got here, this one. Right? Take this expression. This is what we got when we substitute. Instead of k, we put k plus 1. We got this entire expression. And this one also we got. We splitted a plus b to the power k plus 1 as a plus b into a plus b to the power k. Now after splitting, we started multiplying. After multiplying, we took the common factor and then we use this particular property. And finally, you see that you'll get one expression which is same as this. Right? Then we can say, let's call this as equation 2. From 2 and this one, say 3. From 2 and 3, we see that a plus b to the power k plus 1 is this entire expression, which means p of k plus 1 is true. So now, how do we conclude? For n is equal to 1, p of 1 is true. For p of k, we assume it is true. And for p of k plus 1, we prove that it is true. Now, therefore, by mathematical induction, we can say that p of n is true for every positive integer n. So, we took n is equal to 1, we took n is equal to k, then we proved n is equal to k plus 1. So, with all these three steps, we can conclude that p of n is true for every positive integer n. And what is p of n? Nothing but that entire binomial expansion. Let's look at this 47th question. Derive the formula to find the distance of a point p of x1, y1 from the line ax plus by plus c. So you can assume that there is a line here which is intercepting the x-axis and y-axis. And the equation of the line is given as ax plus by plus c is equal to 0. Now since this is the equation of the line, the coordinates, the x and y coordinates, that is, you can call it as point q and point r. So these coordinates would be minus c by a and 0. That is, the x coordinate would be minus c by a, and here the y coordinate would be minus c by b. Right? So we assume that this is the line and the equation of the line is given here. Right? And now we assume that there is a point somewhere outside the line, and to find the distance always from any particular point, we should always draw a perpendicular from that point to the line. So we need to find this distance PM. Right? So now we assume that P, coordinates of P is x and y, and we know the coordinates of Q and R. Right? Now how do we find this length PM? Right? Now if I take area of triangle formula, what is area of triangle? It's half into base into height. Right? And what is base here? Base is this one, QR. And what is height? Height is nothing but this distance PM, the perpendicular. This is area of triangle. Now, if you know this area of triangle, and you can always find the distance QR using distance formula. If you know these two, then you can easily find out PM, which is what we need to find here. Right? Which means PM is equal to area of triangle. Let me put the triangle as PQR into 2. When you shift this 2, it will become 2 area of triangle. Shift this QR below, so it will be divide by QR. So 2 area of triangle PQR by QR. Now, we'll have to find area of triangle. Now, there is a formula to find area of triangle. What is it? It is x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the triangle. We know these coordinates, right? We know QR coordinates, P coordinates. Now we'll substitute these three coordinates. So we can call this as x1, y1. This one is x2, y2. And this one is x3, y3, the R coordinate. Now instead of x1, we'll leave it as x1 itself. Instead of y2, we have 0. Instead of y3, we have minus c by b. Then x2, instead of x2, we have minus c by a. Instead of y3, we have minus c by b. And minus y1, we leave it like that. Plus x3. What do we have instead of x3? 0. So 0 into anything is 0. So let's leave it there. So we'll get half into x1 into c by b. And here you'll get minus c by a into minus c by b. It will become c by b. Then minus into minus is plus c by a into y1. We can take c as common, right? So we'll get half c x1 by b plus you have two c's here. So 1c a into b, ab plus y1 by a. Now we can take LCM. LCM would be AB. This will go A times, only then you'll get LCM as AB. So multiplied by A. So A x1. This will go once. So it will be plus C. This will go B times. So multiply here. So we'll get B y1 by 1 by 2 C. Now we'll just rearrange this. We'll say this is C by AB. C by 2 AB. And ax1 plus by1 plus c. Let's call this as equation 1. This is area of triangle PQR. We have found area of triangle PQR. Now we have to find QR. So what will QR be? We have to use distance formula. QR is, what is the distance formula? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is distance, right? Now we need to find QR. So to find QR, let's substitute in this formula. What is x2? It's minus c by a minus x1. x1 is 0, the whole square, plus y2 is 0 minus of c by b. Right? Basically, you're using this coordinate and this coordinate, QR. So let's simplify. So we'll get root of c square by a square. And here you'll get c square by b square. Now I'll take c square as common. So I'll get 1 by a square plus 1 by b square square root. I can write this as, I can put this c outside. So it will become c. C square will become c. And I can take LCM here. LCM would be a square, b square. This will go b square times. This will go a square times to get this LCM. So I'll get b square plus a square. Now I'll take this outside. If I take this AB outside, it will become AB square root of a square plus b square. Now let's call this equation 2. Now we'll go to the main formula where we have to find the perpendicular distance. We found area of triangle PQR. 2 times, what is area of triangle PQR? Half into c by AB modulus of a x1 plus b y1 plus c. And what is QR? QR is c by AB into root of a square plus b square. So this will get cancelled. 2 and 2 will get cancelled. You are left with ax1 plus by1 plus c by root of a square plus b square. Let's put modulus here. So finally we have derived this equation, right? The perpendicular distance PM is nothing but ax1 plus by1 plus c by root of a square plus b square. Let's look at this particular question where we have to prove geometrically that limit extending to 0, sin x by x is equal to 1, x being measured in radians. So now we assume that this is a unit circle, O is the origin or the center of the circle, and this angle AOC, this one is x radians, and we have segments BA and CD. Both of these are perpendicular to OA, right? You have CD and BA perpendicular to OA, and then you join AC. Join this AC. Now we will write this particular statement: area of triangle OAC, area of triangle OAC, this triangle OAC, where you have joined A and C. So if you look at this triangle OA and C, right, this triangle AOC, right, will be smaller than the sector AOC. Sector means it is having this particular curve, right? Now if you include the curve also, there is some area from this particular AC line and the curve. So that area of sector OAC. So this triangle will be less than this entire sector, this portion, this entire portion, right? Triangle is only this much. The triangle is only OC, OA and AC, right? This is the triangle. Now this area is lesser than the entire sector OAC, and this is again further lesser than OBA, this entire big triangle, right? Now what is the area of triangle OAC? What is the formula? Half into BH. Area of triangle is nothing but half base into height. Now what is base here for triangle OAC? OA. What is height? Height is CD. CD is the height for this triangle. Similarly, for what is the area of sector? So you have to remember area of sector formula, right? Area of sector is nothing but theta by 360 degrees into pi r square. Pi r square is area of circle, and then you have to multiply with theta by 360. What is theta? Theta is the angle. That is angle OAC, this x. So instead of theta, we'll put x. Instead of 360, we put 2 pi and pi r square. What is r? R is nothing but OA, right? R is nothing but OA, so OA square. So you have to remember this area of sector. And the area of triangle OAB is nothing but again half base into height. Base is OA, height is AB, right? Now half and half you can cancel. So you can cancel half here, half here, half here. OA, 1 OA, OA is cancelled. What are you left with? You have CD, then you have X into one of the OAs, X into 1 OA, then you have AB, right? So now OCD in this triangle, what is sin X? Sin X is nothing but opposite side. Opposite side is CD. CD by hypotenuse, OC. CD by hypotenuse, which is OC. Now OC is nothing but equal to OA because it's a radius, right? OC is equal to OA. So we can write CD by OA, right? Therefore sin X is nothing but CD by OA. So now we'll try to substitute this value of CD, AB, right? So what is CD? OA into sin X. So CD is OA into sin X. Similarly, you have X here and then OA here. Leave it like this. Now what is AB? What is AB? So how would we get this value of AB? You can use tan X, right? Tan X is nothing but, tan X would be opposite side by adjacent side. That is AB by OA. This is tan X. Tan X is AB by OA. Therefore, what is AB? AB is nothing but OA into tan X, right? Now, you can cancel OA here. So, you'll be left with sin X less than tan X. So, now we divide this entire expression by sin X, right? Sin X by sin X, X by sin X, tan X by sin X. So, sin X by sin X will become 1, X by sin X, tan X by sin X will become 1 by cos X. What is tan X? Sin X by cos X. And then you have by sin X. This is nothing but, this will get cancelled. I'll be left with 1 by cos X. Now, I'll reverse this because I ultimately want sin X by X. Here I have X by sin X. So, I'll take reciprocal of the entire expression. So, here it will become 1 by 1. Here I'm taking the reciprocal. Here also I'm taking the reciprocal. Right? Now, I'll apply limit x tends to 0 on this particular expression. So, if I apply limit here, limit of a constant is constant itself. Limit of a number is number itself. So, 1. Then applying limit on sin X by X. Right? We leave this like this. Then, if I apply limit on this cos X, right, like this. If I apply limit on cos X, X tends to 0. So, what I'll do is, instead of X, I'll put 0. So, it will become cos 0. What is cos 0? Cos 0 is 1. So, cos 0 is 1. And here I already have 1. Then I'm left with limit extending to 0 sine x by x. Now 1 greater than this limit and again greater than 1. So you have 1 on the left side, you have 1 on the right side, right? Right? Now using sandwich theorem, if you have 1 here and 1 here, then this entire thing in between, the second term also will be equal to 1, right? Only if it is 1, then this equation can be satisfied. 1 greater than 1 greater than 1, right? Only then this equation can be satisfied. Therefore, limit extending to 0 sine x by x is equal to 1. So we have proven this theorem. Now let's look at this particular problem. Find mean deviation about the mean for the following data. So the distribution is given here. So we'll have to first convert this into a table format. So you put all the xi values, all the fi values here, multiply both of these, right? Find the total of fi's, find the total of this product. So you get 340. Now you find the mean. What is the formula? 1 by n into fi into xi, summation of fi into xi. So you found the summation of all these fi into xi, which is 300. And what's the total of all these fi's? It's 40. So 300 by 40, 7.5. This is the mean. Now you will have to find the deviation here. The next column, find the deviation from the mean. So this is the mean, and from each of this xi, you have to find the deviation. So you subtract 7.5 with 2, you get 5.5. 7.5 with 5, you get 2.5. 7.5 with 6, you get 1.5. So like this, you find all the deviations. Then finally, you multiply these deviations with fi, right? So when you multiply 5.5 into 2, 11, 2.5 into 8, 20. So like this, you multiply, total it up, you get 92. Now ultimately, finally, you find mean deviation around this mean. So what is the formula? 1 by n into summation of fi into this x minus mean, right? So now we find the summation. So what is this? We already found it in this column, 92. So 92 and what is n? Total of all these fi's, which is 40. So finally, so mean deviation is nothing but 2.3. Now let's look at this problem. A bag contains 9 discs, of which 4 are red, 3 are blue, 2 are yellow. The discs are similar in shape and size. A disc is drawn at random from the bag. Calculate the probability that it will be red, yellow, blue, not blue. First we'll take red. So you have 4 red, 3 blue and 2 yellow. You have to find the probability that the discs are red, right? The disc that you pull out from the bag should be red. How many red is there? 4. How many you need to pull out? 1, right? So this is the desired outcomes. Probability formula. Desired outcomes by total outcomes. What is total outcomes? 9 discs you have and you have to pick 1. So 9C1. So when you solve this, you'll get 4 by 9. Next one, you have to get a yellow disc. Same thing. How many yellow discs are there? 2. And how many you have to pick up? 1. So this is desired outcome. Total is same thing, 9C1. So we'll get 2 by 9. Next one, it should be blue. How many blue are there? 3. So 3 to pick up 1, 3C1 by total 9C1. So when you find the combination, you'll get 1 by 3. Similarly, not blue. Not blue means you find how many blues are there and then subtract it from 1. That is, you have to find complement. So 1 minus P of B, right? We found blue, third one, this one. So 1 minus 1 by 3 is 2 by 3. Now let's look at part E, related problems. Now let's look at this particular question. Prove geometrically that cos of x plus y is equal to cos x into cos y minus sin x into sin y. Now what we will do is, we will first draw a unit circle. Unit circle is a circle with 1 unit as radius. So you have origin as center and it's a unit circle. So let's draw point, say P1. Let this be point P4, right? And let the angle from P1 OP4, this angle, be x. And the coordinates of this P1 would be cos x and sin x. So because this is a unit circle, x coordinate is represented by cos x and y coordinate is represented by sin x. Now why? How come? What is cos x? Cos x is adjacent or base by hypotenuse, which means if this is the x-axis, cos x is given by adjacent side, this one, which is x-axis, by hypotenuse. In unit circle, this hypotenuse, which is nothing but radius, is equal to 1 unit, right? Now if you look at cos x would be x coordinate, hypotenuse is 1, so it is x. Similarly, what is sin x? Sin x is nothing but opposite by hypotenuse. What is opposite? You can call it as y coordinate. Right? We don't know what this height is or what this length is. So we call it as y coordinate. And hypotenuse is nothing but the radius, which is 1 unit. Which means sin x is nothing but the y coordinate. So we can say that the coordinates of point P1 is cos x comma sin x. And what is the coordinate of P4 now? P4? P4 would be, this radius is 1 unit. So x coordinate is 1. Why there is no y here? Because it's on the x axis, so y is 0. So 1 comma 0. Now we'll plot another point P2. Now let the angle between P2 O P1 this be y. P2 O P1 be y. Now what will be the coordinates for P2? Now let's form this triangle from P1 to P4. Right? So let's try to shade this. Now let's take another point P2, right, somewhere here, and let's assume that angle from P2 to P1, this P2 O P1, right, this angle is y, right? P2 O P1 is y. Now, what is the coordinates of P2, right? We know the coordinates of P1, it's cos x and sin x. Now, what will be the coordinate of P2? If coordinate of P1 with angle x is cos x sin x, then coordinate of P2 with respect to this x axis would be cos x plus y and sin x plus y, right? This entire angle is x plus y. This is y, this is x. So total angle is x plus y between P2O P4, right? So let me draw this triangle P2O P4. Let's take another point. Let's take another point, say somewhere here, and let's call it P3. Let the angle between this x-axis, that is P4 O P3, be minus y, right? Let this angle be minus y. So what will be the coordinates? It will be cos minus y and sine minus y, right? So this would be the coordinates of P3. Now let's draw a triangle from P1 O P3, right? If you join P1 O P3, it forms a triangle. Let us shade it, and then you can also shade this triangle P2 O P4. Now if you notice these two triangles, P4 O P2, triangle P4 O P2, and triangle P1 O P3, P1 O P3 are congruent. Now how? If you have between two triangles, if two sides and the angle between those sides are same, then we can call both the triangles as congruent. Now let's take this green shaded triangle, which is P1 OP3. Here OP1 is radius, OP3 is also radius, and now we'll look at the triangle P2 OP4, this yellow color shaded triangle. Here again OP2 is radius and OP4 is also radius. So now both the sides in both the triangles are same. Now let's look at the angle. Which angle? Let's look at P1 O P3, this angle. What is P1 O P3? It's nothing but x plus y, x plus y. Though it is minus y here, but if you look at the total angle, it will be x plus y, right? So angle P1 O P3 is x plus y, and if you look at angle in this yellow color shaded triangle, angle P2 O P4, P2 O P4 is y plus x, is y plus x. Now we look at both the angles are same, sides are same, therefore both these triangles are congruent. Now in congruent triangles, third side also will be same. Third side of both triangles will be same, will be equal, right? Now what is the third side for P1 O P3? P1 O P3, third side is P1 P3. P1 P3 should be equal to, what is the third side for this yellow shaded triangle P2 O P4? P2 P4. That's the third side, P2 P4. P2 P4, this is the third side. Now these two sides should be equal. Now using distance formula, we'll find length of P1 P3, find length of P2 P4, and see if it is equal, right? First we'll take P1 P3. So we'll use the distance formula, square root of, it will be x2 minus x1 the whole square plus y2 minus y1 the, the whole square and square root. So x2 minus x1, what are the coordinates? we have, let's write it, P1 is cos x sin x, P3 is cos of minus y and sine of minus y. So we'll get root of x2 minus x1. So we will take cos x minus x1, which is cos of minus y, the whole square, plus we'll take the y coordinates, sin x minus of sine minus y, this one, right, the whole square. So this is nothing but cos x, cos of minus y is cos y itself, the whole square, plus sin x, sine of minus y is minus sin y, sine of minus y, sine of minus theta is equal to minus sine theta. So if I bring minus outside, it'll, minus and minus will become plus. So I'll get sine y, the whole square. So now I'll simplify this. So I'll get cos square x plus cos square y minus 2 cos x cos y plus sine square x plus sine square y plus 2 sine x into sine y, and then root. Cos square x plus sine square x is 1. Cos square y plus sine square y is also 1. Then we are left with 2 cos x into cos y plus 2 sin x into sin y, which is nothing but 2 minus 2 cos x into cos y plus 2 sin x into sin y. I'll just eliminate the square root. So I'll say P1, P3 the whole square is equal to 2 minus 2 cos x into cos y plus 2 sin x into sin y. Now let's call this as equation 1. Now let's go to the next side, P2, P4. Let's find P2, P4 the whole square using distance formula again. So what is P2, P4? P2 is this coordinate and P4 is 1, 0. So we'll write this P2, P4 the whole square is equal to, so P2 is nothing but cos x plus y into sin x plus y. P4 is 1, 0. Right? So now we'll use this distance formula. So x2 minus x1. So I will take it as minus cos of x plus y the whole square plus 0 minus sine of x plus y the whole square, which is nothing but, we'll expand this, so it will be 1 square plus cos square x plus y minus 2 cos x plus y, and this will be square, right? So it will be plus sine square x plus y, right? We have the whole square here, so it will be sine square x plus y. Now cos square x plus y plus sine square x plus y is 1. So you get 1 and this together is 1 minus 2 cos of x plus y, which is nothing but 2 minus 2 cos of x plus y. Because the triangles are congruent, P1, P3 is equal to P2, P4. Let's call this as equation 2. So what is equation 1? This entire thing. Let's copy this. And this is equal to, now if you look at, both of these need to be equal, right? This entire thing needs to be equal with this. So I can take 2 as common. I'll get 1 minus cos x into cos y plus sin x into sin y. Here I'll be left with 2 into 1 minus cos of x plus y. Now this 2 and 2 will get cancelled, and here 1 and 1 will get cancelled. So I'll be left with minus cos x into cos y plus sin x into sin y is equal to minus cos of x plus y. So I can rearrange these terms, right? I can shift this here and this one here. So when I shift this here, this minus will become plus. So it will be, and when I shift this here, this minus will become plus. So it will be cos of x plus y is equal to, I'll shift this entire thing. So it will be cos x into cos y. When I shift this one also, it will become minus sin x into sin y. Now if you notice, we have proven this particular expression geometrically. Cos of x plus y is equal to cos x cos y minus sin x sin y. Now let's look at the next problem. Derive the equation of ellipse in the standard form, x square by a square plus y square by b square is equal to 1. Now here, you first draw an ellipse. You have to put two focal points f1 and f2 and assume that there is a point xy here. Assume that there is a point xy here, and the coordinates of f1, coordinates of f1 is minus c0 and coordinates of f2 is c0. Basically, you assume that this distance from origin to f is c, right? And this distance from origin to f2 is c. Now, here it's negative x-axis, right? So, therefore, it's going to be minus c, right? It's x-axis, negative x-axis. So, it's going to be minus c and it's going to be plus c here. And you assume that coordinates of p is x and y. And also, you know, a is nothing but the distance from origin to the major axis. Now, this is the major axis, right? This is the major axis, and again this side also you have the major axis. So PF1, we know that PF1 plus PF2 is 2 times A, 2 times this semi-major axis. PF1 plus PF2 is 2 times major axis. So we know that PF1 plus PF2 is 2 times semi-major axis. This entire thing is major axis, and this distance from origin to this point is semi-major axis. Now, using this particular thing, we'll find the distance. What is PF1? PF1, use the distance formula. X minus of minus c, the whole square, plus y minus 0, the whole square. Then, plus, you take this PF2. What is PF2? X minus c, the whole square, plus y minus 0, the whole square. Right? And you equate this to 2a. Equate this to 2a. Now, when you simplify this, you will get x square by a square plus y square by a square minus c square, right? Now, a square minus c square is b square, right? A square minus c square is equal to b square. What is b? It's the minor axis. So, when you get this a square minus c square, substitute b square here, because you want the equation in terms of a and b only. You want to eliminate c. So, a square minus c square is equal to b square. So, you'll get x square by a square plus y square by b square is equal to 1. So, therefore, we can derive this equation of ellipse. Now, let's look at the next problem. Find the sum of the sequence 7, 7, 7, 7, right? We have this list of terms. You need to find the sum of the sequence or find the derivative of this particular expression. Now, we'll first find the sum of the sequence. So, we'll take 7 as common. So, we'll get 1 plus 1 plus 1, 1, 1 plus up till n terms. Now, you multiply and divide by 9. The entire thing you multiply and divide by 9. So, you get, when you multiply, you'll get all this 9, 9, 9, 9, all this to up till n terms. And you are dividing by 9. So, you get 7 by 9. Now, you can write 9 as 10 minus 1. Right? You can write 9 as 10 minus 1. And you can write 99 as 10 square minus 1, which is 100 minus 1. And you can write 999 as 10 cube minus 1, which is 1000 minus 1, which is 999, up till n terms. Now you can split it. You can write 10 plus 10 square plus 10 cube up till n terms. And this, put minus outside. So 1 plus 1 plus 1 up till n terms, like this. You split it. Right? Now, you can use the formula. The sum of such kind of an expression where you have 10, 10 square, 10 cube till n terms, the formula is 10 into 10 to the power n minus 1 by 10 minus 1. This is the formula. So, we'll have to mug up this. And what is sum of n terms? N itself. Right? Sum of n terms, sum of ones, total of all these ones up till n terms is n into 1. N into 1. So, minus n. Right? And then you have 7 by 9. So, this is the final answer or final summation of this expression. Now, we'll go to the next problem. Find the derivative of this particular expression. Right? Now, you'll have to use the quotient rule because there is division here. What does quotient rule say? Quotient rule is denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. So, using this, you can find the derivative. You will get this expression. Now, what is derivative of x to the power 5? 5x4. Take the power, put x and reduce 1 from the power, so x4. Derivative of cos x is sin x. Similarly here, derivative of sin x is cos x. So simplify this and finally this is the answer. So with this, we've come to the end of this particular model question paper. If you found this video useful, do press a like and share it. Thank you.